This is a description of the CC Chubb job. In this case, we were hired by Chubb to create a series of 3D models of the state of the Funda Dam in Brazil that collapsed and resulted in several deaths and a lot of damage. Chubb was going after the owners and operators of the dam, who was Vale, and pointing out the mismanagement of their tailings dam in Brazil, and how the mismanagement of that dam led to its collapse. The idea here was to show the state of the dam over a period of several years, starting back in 2008 and leading up to its collapse in November of 2015. So we ended up producing about 33 three-dimensional models of the dam at various states in its construction. The general idea was, let me start with a simple view to demonstrate the time sequence of what the structure of the dam looked like. So the top level view is here. We have number one is the empty mountain valley and a series of concrete drains that were laid in the bottom of the valley, and then some initial dirt dams or sand dams that were to hold the tailings from an iron ore mine, which is somewhere up in the hills above this site. The idea was that there are two things that come out of the tailing, or the two types of tailings that come out of the dam. One are sand, which is just sand and water, which were intended to be stored behind this lower dam. And then there's another material called slimes, which is a clay mix, and it's very slippery. It's just like a very wet clay. The problem is that it doesn't drain. It just stays kind of gooey and slimy and slippery, and hence the name slimes. The idea is to keep those two types of material separated. Sand down here will pack down, and if you drain it properly, will become nice and tight and form a good barrier to hold back the slimes as the development of the dam goes forward. And it soon became apparent that Vale was violating the terms of their design of the dam, in that they had slimes being deposited down here way too close to the sand dam. And this was a result of changes in their mining volumes, and they had too much slime to deal with, and so as a quick solution, they just dumped it downstream, which was a bad idea in the long run. So we've got a time lapse. I'll just step through this here as we go up in dates. You see the valley filling up as they add more and more slime to it, and they keep adding berms here to the earthworks dam to hold it all back. And we've got a good series of satellite photographs and drawings that describe the external structure at various states. It's sort of an immensely complex process, partly because all of this is sand, and they change it. Even though certain layers look like they're fixed, they get moved at some points in time, and of course the valley's always filling up, and there's different boundaries of slime at different days where they've dumped in more slime. The problem with this was that they ended up with a structure that wouldn't drain, and we've got our special contribution to this was to illustrate the structure of the dam without the sand getting in the way. So that what you can see back here is every day that they added slime that wasn't supposed to be down in this area, you can see a buildup of those layers. So they had slime stacked on top of sand, which was stacked on top of slime, and these structures wouldn't drain. So this was a sort of a wet, sloppy mix of stuff that wasn't stable. And on November 15th of 2015, there was a small earthquake that came along and shook this valley, and this whole structure was sort of like jelly, and it just liquefied and flowed downstream, wiped out a village, killed several people, and I think it took 2 weeks and eventually ended up flowing down and hitting the ocean. So it was just a massive amount of stuff that came downstream. One of our key graphics we produced was this sort of top-level summary showing the design intent of the dam was to have this first dam down here that would hold back the sand, and have the second dam here that would hold back the slime, and have a 500-meter boundary between them. The design then shows, this mountain valleys and ridges, or gullies and valleys filling up with slime. And then what actually happened was everything should have been back here in the pink area, and all this brown orange stuff was slimes that were in violation of the design down here, too close to the front dam. And of course there's sand stacked on top of that, and all of that was in violation of design and set the stage for this thing to collapse when the earthquake came along. So back to our dam history, we've got a huge setup here in the image loader where you can jump to any particular date and time, and then we gave 4 different views here: plan view, another plan view, and 2 elevated views. The intent was to do a full image loader orbit and 4 or 5 layers of tilt and 2 layers of zoom. Turned out we just did not have time to do the renders because there was many thousands of frames to render to implement that, so we had to back off and just do these 4. But once you're parked in any one position, as you move forward in time, your view stays in that position, and you can see the new structure accumulate. And you also have the option here to turn on sand or turn off sand to see what is accumulating underneath the current structure. There's several places too where we incorporated some other marks and graphics, maps indicating where leaks were occurring, areas where water was ponding and would not drain, indicative of a poorly executed dam. This water and stuff is supposed to drain off of here. There are a couple of places where we've done a photo match, and that's interesting. I don't know why that doesn't work. I'll have to check it. Here's a couple of places where we actually did an animated zoom in to go down on the surface of the dam and then fade to a photograph that shows the cracks on the surface that were appearing, that were indicative of a poorly built structure. Maps of the cracks, photos of the cracks. Here's a guy standing next to the cracks. A little bit of photographic evidence of how those things looked. The other case where we did several of these, where we matched a photograph to the structure, just to show, this is our model with our interpretation, or the expert's interpretation of where the slimes were, and then fade right to a aerial photograph where he's annotated the location of the ponds and the slimes. So it was quite an interesting project. It was very tedious. The client didn't quite get on board with what we were doing, and we had a great deal of difficulty working with the data they supplied. They had tons of data, tons of photographs, tons of drawings, but as we found out, nothing lined up. These are all based on satellite photographs that were all slightly different than each other. They were rectified differently after they corrected for tilt and camera angle, and when you compared one to the other, they didn't match, and so we had to do a huge amount of work to try to make a mechanical structure that would demonstrate what they needed and show the evolution of the dam over time. But the big feature that I think the client really appreciated was having this sand off view where you could see the accumulation of all of the bad stuff that was going on underneath there, and that helped them reinforce their point that this dam was not properly uh, operated. It was designed okay, and it would have held if you had maintained that design, but they violated that and let slimes intermix with the sand, and ultimately led to the collapse when the earthquake happened.